In this unit, we're looking at polynomial functions of a higher degree. We've already worked with quadratics and cubic functions. We know what the graphs of those look like. Really what we're looking at here is just in general, if I have something that is to an even degree, like x to the fourth. We have a general idea what that's going to look like. First of all, an even number tells us that our end behavior, either it's going to be going both up or both down. Now an x to the fourth a lot of the time kind of looks like a w, and because the leading coefficient is a positive 1, just like with the parabola, it's opening upwards. If that was a negative value, it would be opening downwards. Whereas if we have something like x to the fifth where it is odd, very similar to x cubed, we might have something coming here winding across. And so now we're looking at that end behavior where here as x is approaching negative infinity, our y values are also approaching negative infinity. And as x approaches a positive infinity, so does y. So if it is even, either it's going to be both up and both down for that end behavior. If it is an odd degree, then they'll be opposite of one another. Now some different things that we can talk about with this. If we say that a graph is smooth, then that means that all these curves are smooth, whereas something like if we're looking at the graph of absolute value, we have that sharp point, and that is not smooth. It would be sharp. So we can sketch graphs and have some ideas there. When we're sketching the graphs, the first thing we look at is the degree and the leading coefficient. Again, that leading coefficient, if it's a positive number, then we know that for those degrees that are, when we're looking at the degree, we're looking at is it even or is it odd? And for that leading coefficient, we're looking at is it positive or is it negative? All right, so both examples up here, we have an even degree opening upwards, an odd degree coming this direction. That was even and odd, both positive. If I have an even degree that is negative, then that's going to be something just like a parabola. Now we're saying even degree, but an odd, even degree, but a negative leading coefficient is going to open downwards. If we're talking about an odd degree, over here is odd, and again, if I have that negative leading coefficient, now we're going to come across this direction, maybe something that way, where, again, now as x is approaching negative infinity, y is approaching a positive infinity. As x approaches a positive infinity, y is approaching a negative infinity. So with an odd function, they would be opposite one another. Now, the other thing we're going to look at when we're talking about these are zeros. Now, when we're looking at the zeros, again, that's where we're talking about this is crossing the x-axis. And if we're talking about real zeros, we're talking about real numbers. And something we can look at is, first of all, we can look at the factors. If we can factor something, the factors will tell us what the zeros are. And something we have to watch for when we're doing the factoring is that a double root or a repeated root. Because if we are looking at something that is a fourth degree, we're expecting it to have up to 4 zeros. A fifth degree, we're looking at it to have up to 5 zeros. We'll get more into that later. But if we have something like f of x is equal to negative 2x cubed plus 6x squared minus 9 over 2x. And we're going to, first of all, let's try and factor this. The 1/2 here and all these, the negative leading coefficient, makes me want to factor out a fraction. If I can get that to go to a whole number, I see they all have x's. So if we factor out a negative 1/2 x, if I take that out of each term, negative and negative makes that positive. So now we have, again, I'm factoring that out. That's going to be 4x squared. Factor out a half of that, that's going to make that, and this was positive now. It's negative 12x and plus 9. And so if I were to distribute that negative 1/2, I go back to this original equation. And now factoring for this, that would factor, and if I'm going to do the factoring to get the 4x squared, I can think of a 2x and a 2x. It's going to be minus 3 on both. Remember, the big thing to look for is if I look at the outside and the inside, it should give me that middle term. So when we're looking at this, our f of x, when we have this in factored form, it looks like negative 1/2 x times the quantity of 2x minus 3 squared. That's a double root or double factor. And so when we're looking at this, when we look at I can set both of these equal to 0 to find our zeros. So negative 1/2 x equals 0 means x equals 0. Here we're going to say 2x minus 3 equals 0. Add the 3, divide by 2. X equals 3 over 2. And so we found our zeros. And if I were to sketch a graph of this, based on what I know right now, think about the original equation that we had. I have a negative 2 for my leading coefficient. I have an x cubed, so it's an odd function. I now have found out that I have a 0 there, and then at another 0 where x equals 3 over 2. But remember, that was a double root. So when I look at this graph, and I look at approximately where 3 over 2 is, and I don't have any units on here, so we're just going to say it's going this direction. A double root is going to be a min or a max value as far as a local min or a local max. And so this graph, because of the negative leading coefficient, I know it's going to go up this direction. It's going to come across here, come back up, and just touches at that point and then heads back down. So that is a local max on that one. Now, something else we're looking at within this section is if we talk about the standard form. When we're writing these polynomial functions. First of all, in standard form, what we're saying is that the exponents will be written in descending order. So what that means, I could have a function like g of x is equal to, maybe it's x to the 5th, to x to the 4th minus an x cubed plus an x squared. We can see how these exponents are counting down. Minus x, and then whatever constant we have on the end there, some sort of a constant, plus 0, plus 1, minus 2, whatever it might be, plus our constant. And so that would be standard form, where we have these, it's all in one form, it's not factored, all right? So it's in our standard form, and those exponents are counting down. So let's look at another function. Let's say we have h of x is x cubed minus x squared plus 1. And if we're going to graph that, and I already know what the graph looks like, we can use our graphing calculator here. There's some key points that I know of. I know that it's going through -1, -1. If I make a little table here, it's going to go through -1, -1. It's going to go through 0, 1. It's going to go through 1, 1. So I'm just looking at those points right now. So let's say that this is our -1, -1 here. And here we're at 0, 1, and then I have another point over here that's at 1, 1. It's x cubed, so it's going to come across here. This direction makes a dip and heads that way. So some different things that we can look at with the graph here is, first of all, in between -1 and 0, and I'm talking about the x values. So in between -1 and 0 for our x values, I see that I go from a negative number to a positive number. So using the intermediate value theorem, I can conclude that there would have to be a 0 in between there. I know that this is a continuous graph. It's continuous because I can draw the whole thing without ever having to pick up my pencil. And so if I see that with my x values in between -1 and 0 that it's going from a negative to a positive, I know somewhere in between there that there's going to have to be a 0 on this particular problem.